In this problem, we have Ashley going down a slide, and we're given a coefficient of kinetic friction, and we are asked for acceleration. So this word right here tells you that this situation is not at equilibrium. So we can draw our slide. It's at 46 degrees to the horizontal. So that angle between here and the horizontal is 46. And now we can draw the rest of our free body diagram. There's Ashley. And there's her weight, her gravity force, and it's 450 newtons. We know because she's resting on a surface, there's a normal force. And because she's moving, and we didn't say ignore friction, that there is kinetic friction. And we also know that the coefficient of kinetic friction is 0.22. We can break our weight into x and y components. We have FGX and FGY, and this 46 is also here. It's really close to 45, which means our x and our y components are going to be really close to equal to each other. So now we can look at our free body diagram and then we can evaluate what we know. So because there is acceleration, we know that the sum of the forces in the x direction does not equal 0. The sum of the forces in the x direction is equal to your net force, because those words mean the same thing. And your net force in the x direction is equal to your FGX minus FFK. We know that the net force is what causes the acceleration. And since we know that we are asked to solve for acceleration in this problem, we can derive or rearrange this equation in order to solve for acceleration. So we know that we'll need mass, and we'll need our x component, and we'll need our FFK. We know that this equation here will give us FFK when we have normal force. So the sum of the forces in the y direction is equal to 0 because she is not accelerating in the y direction or even moving in the y direction. So we know that FGY is equal to our normal force. So we can find a lot of the information we need if we break our weight into the x and y components. So let's go down a little bit. We have FG equal to 450. We have FGX. We have FGY in a 46-degree angle. So our x is opposite, so we will use so. So our sine of theta is equal to our opposite over our hypotenuse. So the x component of our weight is equal to 324 newtons. And we'll need this piece of information to solve for our acceleration. And if we look at our y, it's adjacent, so we will use So our cosine of 46 is equal to the y component of our weight divided by 450 newtons. So our F of gy is equal to 313, which is also equal to our normal force because of this. So the only component we're missing in order to solve for our acceleration here, we have the F of gx. We don't have the mass yet. We can solve for the mass in a minute. And we have F of k, which we don't have, but we know that F of k is equal to mu k times the normal force, which is here. And we were given the coefficient. It's equal to 0.22 times 313. So our friction force is equal to 68.9 newtons. And now we can find our mass. If we do weight divided by 9.8, we will get that our mass is 45.9 kilograms. Now we can solve for our acceleration. Acceleration equals F of gx, 324, minus F of k, 68.9, divided by the mass. And when we round to the correct two significant figures, we get that our acceleration is 5.6 meters per second squared.